Hi to all. I hope you all are doing good and fine. So I'm back with my video number 3, and in this video I'm going to cover the concept of supplementary units. And as usual, here are some statements written over here this page, and I will clarify each and every statements in detail. So let's start. So I'm going to start the supplementary units. According to SI system of units, there are 2 supplementary units, and the first one is plane angle, which is measured in radian, and the second one is solid angle. It is also called angle in 3 dimension, and it is measured in steradian. So first let me discuss the concept of plane angle, and we are all familiar with this concept. Now suppose this is a circle, and A and B are 2 points on the circumference of this circle, which having arc length S. If R is the radius, then theta is the angle, right? And we are all familiar with this equation also. This is what arc length is equal to radius multiplied by the angle, right? And if I rearrange this equation, then I can say theta is equal to S by R, right? And here I want to emphasize on this theta is measured in radian, not in degree. And this relation actually do what? It establishes a relation between a curve length, S is what? It is basically a curve length, and R is a linear length. Why radius is a linear length? Because the radius is measured along a straight line between 2 points, right? Now suppose if O is the center of this circle and A is any point on the circumference, then the radius is measured along the distance OA, right? So in that sense, R is called a linear length, right? Now, this radian is actually, what the meaning of this radian? Radian unit of angles tells you about how much times the arc length is of radius of the circle, right? Now suppose if you put the value S is equal to 1 meter and R is also equal to 1 meter, then the theta comes out to be 1 radian, right? If I increase the value of S, it become 2 meter. For the constant value of R that is equal to 1 meter, then theta comes out to be 2 radian, right? What does it mean? 2 meter arc length traces 2 radian angle at the center, right? Now I think it is clear to all of you. Radian gives you the idea how much time the arc length is of radius of a circle, right? Now let me discuss what happened if this point completes a 1 full rotation of the circle, and here you can see this is the 1 full rotation, and the arc length in this case that comes out to be S equal to 2 pi R, which is equal to the circumference of this circle. If I put the value of S over here, then the theta which comes out to be here 2 pi radian, right? So the angle in 1 full resolution is, or revolution is, comes out to be 2 pi radian, and that is in our knowledge that theta is 360 degree. If I talk about this angle in terms of degree, then it is theta equal to 360 degree, and it is for in 1 rotation or revolution. So this is the angle in 1 revolution, this is the angle in 1 revolution, so I can say these two must be equal to each other, right? So here I can equate 2 pi radian is equal to 360 degree. And from here you can say 1 radian comes out to be 57.3 degree. And of course 1 radian is greater than 1 degree, right? So what we did here, we explained the meaning of radian, and I hope it is clear to all of you. Now let me discuss with you the important questions here. That is why the unit of angle is kept under the category of supplementary units. Well, the answer of this question is very simple. Now, if you see what is this theta basically, theta is what? S by R. And we know this as is a kind of arc length, and this R is a linear length. I already discussed with you how this is a linear length, right? Now let me write down another formula of longitudinal strain here. And you know what is this? This is change in linear length divided by original length, right? And if you make a diagram over here, this is the original length L, and this is the change in length. Now suppose it is 5 meter, and this change comes out to be 0.5 meter. And if I put this value here, then this value comes out to be 0.1. And of course, meter is cancelled out here. That will give you a numerical value, right? Is there any associated with this longitudinal strain? Of course not. It is a completely a numerical quantity. Now let's see what happening here. If you see this arc length is equal to, let's suppose it is 1 meter, and this linear length is also 1 meter, and it comes out to be a numerical value, right? Is it a numerical value? Yes, of course. Then, okay, you might say that both are identical cases, but it is actually not so. What is the difference between these two? Let me clarify this concept here. Now, if you notice here in this equation, this is a kind of a length, which is basically a linear length, right? And this length is also a linear length, right? Now, if you notice here, what is this as? This is the arc length, and this radius is the linear length, right? If we see, these two are different from their geometrical perspective, and supplementary units of system take care of this difference, and this system treats this difference very specially. So that's why supplementary units define radian for this difference. And I hope it is clear to all of you. But there's no such difference exists here, right? This is the linear length, this is the linear length. But here in this case, in order to treat this difference of geometrical perspective, this system defined a radian for this. So that's why theta is defined in terms of radian. And I hope it is clear to all of you. If you have any doubt, any question, then you can do your comment in the comment box. I will definitely reply your comments, right? So now let's move ahead. But before going further, I just want to go through some basics. So let me scroll it down. Yes. Now you can see this is a sphere. Let's suppose that this is a sphere, and you are sitting at the center of this sphere, right? And we know very well that the diameter of this sphere is normal to the every part of the circle, right? Now suppose these are four different surfaces which are present on this hypothetical sphere. And if you try to look this surface, then you should see this surface along this direction. Similarly for this and this. So basically what the thing is happening here, this represent basically the line of sight, and it also represent the normal to this surface also, because the radius is normal to the every part of this sphere. So here we can say that both line of sight and normal are in same direction, right? Similarly for this, and similarly for this and this also, right? Now suppose if you have any arbitrary surface here, and if you try to look this surface, then obviously the line of sight will go along this direction, and normal to the surface is along this direction. Right? So here is some angle theta in between the direction of line of sight and the normal. So the one thing which is very pretty sure to you, that this surface element is not present on any hypothetical sphere which having the center O, right? It might be present on any other hypothetical sphere which having a different center other than O, right? So you just keep this thing in your mind. I will be come to this point ahead in this video. So let me scroll it up. So basically what the solid angle is, angle in 3 dimension, and it gives you the sense of how big or small any object appears from point of observation. And solid angle is constructed by joining the periphery of surface element at the eye location, and it is calculated by considering normal component of surface area of surface element to the direction of view. So what is this direction of view? Basically this is the line of sight, right? So now I just want to go through this diagram. Here in this picture you can very clearly see that it is a kind of a disk. Let's suppose it is a disk D1, and here it is a point which is basically a observation point. And now if you want to look this disk D1 from observation point, then this line represent line of sight, and this line also represents the normal to this disk D1, and of course both are lying in the same direction. So what I can do, I can construct a hypothetical sphere which having the center at O, right? And if this thing is happening, then what does it mean? The disk D1 is the part of this hypothetical sphere which having the center at O, right? And the next thing which I can do, I can meet the all points of this disk D1 at the observation point. So in this way, I have constructed a complete cone. Now at this instant of time, you should ask one question here: what does this small surface element represents? Well, this is basically what? This is the appearance of disk D1, and it is nothing but this is called solid angle, right? Now you should ask one more question here: how this thing represents the appearance of this disk D1. Now to answer this question, I want to show you something here. So for this, let me scroll it down. Yeah. So here in this pic, you can very clearly see that it is a kind of a wire which is hanging on the wall. And of course, the wall is situated at some distance from my eye. This is a pen which is extremely close to my eye. And in reality, both of these objects are of different height, but in this pic, you can very clearly see that both are appearing of the same size, right? Now the question is how this thing is happening, and what does this pen represent? Well, the pen represents the apparent size of this wire which is hanging on the wall, and this thing is happening because the ray starts from this wire that goes to the observation point, and these rays which start from this point of this wire that exactly fit the size of this span at the observation location. And it is exactly the same thing which is happening here in this case also. The ray starts from this disk D1 that go to the observation point, and that exactly fit the size of this smaller surface element, right? And at this location, both of these objects appear of same size, right? I hope it is clear to all of you how this thing is happening. Now, this is the time to discuss the concept, how we can calculate the solid angle, how we can find out the expression for this. So here in this diagram, you can see this is the disk D1. Let's suppose it is a disk D1, and O is the observation point, and this line represent the line of sight, and this is the normal to the surface disk D1, right? And up to this point, you are very familiar with this concept. If the line of sight and the normal are not lying along the same direction, then this disk D1 is not the part of a hypothetical sphere which having the center at O. It might be the part of a hypothetical sphere of another sphere which not having the center at O, right? But at this point, I need O as a center of the hypothetical sphere. So for this, I would be needed a surface which is normal to the line of view or line of sight, right? So what I need to do, I need to do the component of D1, and this surface is basically what? The normal component. Normal component of D1, right? If you draw the normal to this surface, then it comes out to be it comes out to be along the same direction as the direction of line of sight, right? Now you can say this surface is the part of a hypothetical sphere, right? And the next thing which you can do, you can meet the whole point of this surface to the observation point. So in this way, you have constructed a complete cone, right? Now, I need to draw this diagram separately, which I'm doing here. So this is basically what this line, and here you can suppose this is the small surface element, which is basically what? The appearance of disk D1, and it is nothing but the solid angle, right? So I will be doing the mathematical calculation for solid angle by considering this figure. So I need to label it. Let's suppose this is the point A, this is the point O dash, and this is O double dash. And now let's suppose this is point A, this is B, this is C, and this is D, right? So here in this triangle, you can find out the two triangles, which are basically the triangle O dash D and triangle O double dash C, right? And you can say these two triangles are similar triangles. So by the property of similarity of two triangles, I can equate the corresponding ratio, the ratio of corresponding sides. Let's suppose I'm taking OO dash divided by OO double dash is equal to the O dash D divided by O double dash C, right? Now, in the next step, what I do here, I do the square of both of the side, then it gives me O double dash squared, O dash D squared, O double dash C squared, right? And in this step, what I do, I multiply this by pi and I divide this by pi, right? And if you notice here, what is this quantity basically? Pi O dash D square. So let's check what is this quantity here. O dash D square, which is basically what? The radius of this small surface element. And if you multiply with pi, then it gives you the surface area of this small surface element, right? So let's suppose this is dA, right? And here this pi O double dash C square, that will give you the surface area of this disk, right? Now I need to do some small calculation here. Now suppose if this normal represent the surface area of this disk D1, then this normal to the normal component of this surface element will represent the surface area of this disk, right? So I can do what next? I can substitute the value of this and this, right? So here let's substitute the value of pi O double dash C square. So it is basically what? And this is ds cos theta, and here this is OO dash. I am taking this as unity, say it is 1, and OO double dash it is R, so it will give you the R square, right? Right. Now you should ask a question, why I'm taking this OO dash equal to unity. So if you see this diagram very closely, then OO dash is basically what? This much distance. I'm taking this as unity because this is basically what? The appearance of the disk D1, right? Which is extremely close to the eye. So I can take this distance as much as possible. So for simplicity, I'm taking it as unity, right? And here you can say this distance is equal to R, smaller, right? And I can expect that it is clear to all of you what I did here. So if you rearrange this equation, then it gives you dA equal to ds cos theta divided by r square. So this is the final expression which we are interested in to find out. So in this equation, what is this dA? dA is the surface area of this small surface element, this one, and it is basically what? The appearance of a disk D1, and it is also called solid angle, right? So what is this dA? This is solid angle, right? And here, what is this ds cos theta? This is normal component of disk d1, right? And what is this r? This is the distance of surface element from the point of observation, as you can see it very clearly here. So now finally what I want to do, I want to apply this equation for calculating the solid angle for a complete sphere. So for this, what I'm doing, I'm selecting any arbitrary surface on this hypothetical sphere. And now suppose this is the center O, and this is the line of sight, and this line of sight also represent the normal to this surface element, right? And I can connect the all points of this arbitrary surface to the observation point like this. So in this way you can complete a complete cone, right? So here, if you want to apply this equation, then you can obviously say that cos theta is equal to 1 because theta is equal to 0 degree, right? Why it is 0 degree? Because both angle to this surface element and the direction of sight, line of sight, are along the same direction. So if you write this equation again, then it is ds by r square. Now in this case, what is this ds? ds is the surface area of this surface element, right? And if you want to find out the solid angle for a complete sphere, then what I need to do, I need to integrate this equation, right? After integration, that will give you a complete solid angle, which is basically a. Let's suppose it is a, and you can take it out 1 by r square outside this integral sign, and you are just left with this. What is this quantity here? This is nothing but the surface area of this hypothetical sphere. Obviously, now you just can imagine that if this surface element expands in such a way that it covers the whole surface area of this sphere, then obviously this value comes out to be 4 pi r square, right? And finally, you are just left with this quantity here, which comes out to be 4 pi, right? What is this 4 pi? This is steradian. This is the unit of solid angle, right? Now, finally, I want to mention one important point here. Did you notice one thing throughout this lecture? I mention everywhere the surface element. Here also I talk about the surface element, right? And here also I talk about the surface element, right? And here, right? Now you should ask a question: can we draw a three-dimensional object? Yes, we can. Because whatever be the subject is available around you, then you just can see only the surface, particular surface of any object, whether it is a two-dimensional, three-dimensional, or a one-dimensional object, right? You cannot see the all angles of this particular object unless or until it is moving, right? Or you are moving all around it, right? So that's why it is the reason I talked about a surface element everywhere in my this video lecture, and I expect it is clear to all of you what I mean, right? So finally, I think it is enough for the day, and if you have any doubt, any question, then you can do post in comment box. I will definitely reply your comment. So it's enough for the day, and in the next video I will come with some new concepts. So till then, goodbye.